Okay, everyone, GPs, otherwise known as geometric progressions. All right, geometric progressions. Okay, do you remember C1? And in C1 we did APs, which were arithmetic progressions, and they looked something like this, didn't they? 3 plus 5 plus 7 plus ... And we called the first term U1, or we called it A, and we went to see what they were going up by, and in this case they were going up by 2, so we called the difference 2. So those were APs. Okay, we've got 6 sequences here. Let's just grab one of them. Let's grab this one. A is obviously 2, and you can see that it's definitely not an AP because we're not adding on the same amount to get the next one, are we? We'd add on 2 and then 4 and then 8. So let's have a look at something else. Instead of adding to get the next term, do you notice that we can multiply each time by 2? So each term is double the previous. Now, if you notice that you have this common, which means obviously the same, multiplier, and I don't call it a multiplier, I'm going to call it a common ratio. So the thing that you're timesing by, if you notice that that's the same, then you have what's called a geometric progression, otherwise known as a GP. And in this case, the common ratio of the thing you're timesing by is called R, and in this case, R is 2. Okay, it's actually not a progression yet, it's actually a sequence, and to make it a progression or a series, we'd need the commas to become pluses. Okay, let's have a little look at another one. This is quite a good one here. Let's have a look at this one, 2, 4, 16, 32. Is it a common ratio? So are we timesing by the same thing each time? Times 2 to get 4, times 4, times 2. Right, it's definitely a nothing because can you see the common ratio is not the same? Okay, let's have a look at this one. 10, 100, 1,000. A is 10, and are we timesing by the same? Yes, we are. Can you see we're timesing by 10, and therefore this is a GP with A10 and R as, yes, A10 and R is 10, isn't it? All right, let's have a look at this one. This one here, A is 3. What's the actual ratio? Is there a common ratio? Are we timesing by the same? Well, to get the next one, we times by -1. And to get this one, we times by -1. And to get this one, we times by -1. So it's a bit of a strange one, but it's definitely a GP where R is -1. And the last one we're going to look at is this one. A is obviously 1,000. What do we need to do that? Now, the common ratio is only ever what you times by. So actually what I would need to times by is I would need to times by 1/10 there, and in here I would need to times by 1/10, and therefore it's definitely a common ratio. It's a GP with R 1/10. All right, we don't talk about what we divide by, it's only ever what we times by. Okay, we're going to look at the nth term of a GP. So let's just have a little look at what's happening, and let's just put one up on the screen. So if we had a first term of 10 and my common ratio was 2, I would times 10 by 2 to get 20, and then I'd times by 2 to get 40, and I'd times by 2 to get 80. Okay, and that's what my GP could look like. Okay, so let's start generalising. The first term here is referred to as A, and sometimes I call the first term U1. And then how do I get the second term? So I'm going to call the second term U2. How do I get this second term? Well, what I do is I take the first term and then I times it by the common ratio. So what I'm actually going to do is I'm going to times that by the common ratio, and therefore that will give me AR. So how do I get the third term? So the third term here is found by starting off with an A, timesing it with the common ratio, and then timesing it with the common ratio again. So it's this one now times R, which gives me AR squared. And you can see the pattern, u to the 4 is AR cubed. And of course, this is a GP. It's a progression, so we're going to put the pluses in. Now, we're looking for the nth term of our GP. And the nth term of our GP is found by u to the n. So we're actually wanting this term over here, this one up here, ... Now, it's pretty easy to spot the pattern because if you have a look here, you can see, you've probably spotted it already, that u to the 4 is, there's the u to the 4, is ar cubed. U to the 3 is ar squared. And I'm hoping you're spotting that u to the n is ar, and it's one less power. Can you see that? So u to the 3 is ar squared, u to the 4 is ar cubed, u to the 2 is ar to the 1. So it's ar to the n minus 1. So let's just write that out. The nth term, otherwise known as u to the n, is ar to the n minus 1, where a is the first term, all right, so that's the first term, and n is the number of terms. Okay, so put that in. You've got to learn that. The nth term, u to the n, ar to the n minus 1. And of course, don't forget from the APs, it's the same thing. It's sometimes known as the last term. Okay, a really classic question. We're trying to find the 20th term. Now, the 20th term is going to be written as u20. So we're going to write our formula out. U to the n equals ar to the n minus 1. Now, what I'm going to say at this point with the formula is it is only the r that is raised to the power. So it's quite a good idea to pop a bracket round it. Let's now work out what we've got. So a on here, a is 2. And what are they all timesing by? They're timesing by 2, aren't they, each time? So r is also 2. Okay, so now let's pop it into here, and we're going to do exactly what we do when we overwrite it. We're looking for u20, so we're going to overwrite the n with a 20. Our a is a 2 and our r is a 2. So let's neaten up what we have. We have u20 equals 2 bracket 2 to the power of 19. And we're going to do the 2 to the 19 first. So if we do 2 to the power of 19, that's a pretty large number. We get 2 times 524288, and that should come to 1048576. So right, so you can see it gets quite large quite quickly, doesn't it? Find the 20th term. Wow, look at the 20th term. Okay, using the formula in a slightly different way, find the number of terms in the series. So we're going to find the number of terms. So the only thing we know anything about is u to the n equals ar to the n minus 1. And again, it's only the r that's raised to the power. So what do we know something about? We know that a is 2. We know we're trying to find n. We know that the common ratio is 2, isn't it? If we do all of that, we're going to double it each time. So the common ratio is also 2. And we are trying to find the number of terms. Now, do you remember it's exactly like the AP question where this is the last term. So actually this part is u to the n. So in here is going 256. The a is 2, so that's going into there. And the 2 is going into here. Okay, so the first thing I'm going to do is I'm going to get rid of this 2 by dividing both sides by 2. And 256 divided by 2 is 128. So 128 equals 2 to the power of n minus 1. Now, okay, if we've done logarithms, then you can solve this using logs. But actually, this is much easier to solve using logs. I'm just going to have a little kind of trial and error, really. Actually, it doesn't take long to type a few numbers in, but actually 2 to the 7 is 128, which means 7 must be n minus 1, which means n must be 8. Okay, so the number of terms, there are 8 terms in that series. Okay, time for you to have a go. Why don't you pause the video and try and then check the answers? Okay, so checking the answers. Let's have a little look. A is 10. That's for sure. R is, what are we timesing by? It's a half, isn't it? So every time it times is by a half. Okay, so u to the n equals ar to the n minus 1. We are trying to find the 10th term, so we're trying to find u10. So let's start overwriting that. So wherever there's an n, there's a 10. A is also 10. In fact, let's put my bracket in. A is also 10 and r is a half. Okay, so here comes my little heart. There's my r as a half. Here coming in here. Right, okay. U to the 10 equals 10 bracket a half to now the power of 9. Now, a half, 0.5 to the power of 9 is fairly small. I reckon my calculator's telling me that's 1/512. And if we times that by 10, I'm getting out 5 over 256. Okay, another one for you guys to try. So try this one. Find the number of terms in the series. Okay, so u to the n equals a r to the n minus 1. Let's bracket that off so we can see that. There's an r there. So I reckon that a is 10,000. And what are we timesing by? It's a tenth, isn't it? I think it is. I think we're timesing by a tenth. So r is a tenth. Okay, so we want the number of terms. So we're going to go. Now the last term here, the last term, or u to the n, is 1. So let's start overwriting this. That's a 1. A is 10,000. I'm not going to be able to overwrite this, am I? Because I haven't got enough space. R is a tenth, and that's what we've got so far. So let's neaten that up. 1 equals 10,000, and it's not a half, is it? Hang on. It's not a half. It's a tenth to the power of n minus 1. Okay, so the first thing we're going to do is divide by 10,000. So 1 over 10 is 1/10 to the power of n minus 1. Okay, a bit of trial and error, or you could do logs if you know about logs. So a bit of trial and error says that actually this is to the power of 4. So 1/10 to the power of 4 equals that. And therefore, let's have a bit of a think. N minus 1 must equal 4. N minus 1 equals 4. So I reckon n is 5. So the number of terms in the series, there are 5 terms.